Good morning, student. I'll discuss about problem based on electrostatic potential. So my first question is, find the potential at a point due to a positive charge of 100 microcoulomb at a distance of 9 meter. अर्थ कौन? Find the potential. आम गोटे जगार गोटे पॉइंट रे पोटेंशियल कैलकुलेट करवा कहा जो ड्यू टू पॉजिटिव चार्ज जो जार कि चार्ज है 100 माइक्रोकुलम जो पॉइंट रे आमे इलेक्ट्रिक पोटेंशियल कैलकुलेट करबा तार डिस्टेंस फ्रॉम दैट चार्ज इज 9 मीटर. ओके, हियर अगेन आई विल रिपीट दैट क्वेश्चन. Find the potential at a point due to a positive charge of 100 microcoulomb at a distance of 9 meter. Okay, now I'll start that question. So this is question number 1. So this is the source charge having 100 microcoulomb, and this is the point P. At that point P we have to calculate electric potential. That point P, which is situated at distance R, is 9 meter from this charge. So you write, you have to calculate electric potential, and the distance between point P to charge is R equal to 9 meter, and the charge is given by 100 microcoulomb. So here 100 into 10 to the power micro means 10 to the power minus 6 coulomb. So that means 10 to the power minus 4 coulomb. We know electric potential due to point charge V equal to 1 by 4 pi epsilon 0 Q by R. So 1 by 4 pi epsilon 0 means 9 into 10 to the power 9. Q means 10 to the power minus 4 divided by R means 9 meter. So 9 cancel out. So 10 to the power 9 and 10 to the power into 10 to the power minus 4 is given by 10 to the power 5. That can be represented as a volt. SI unit of potential is volts, और हम लिखी परिबा न्यूटन मीटर पर कूलम. So this is the electric potential at point due to charge is given by 10 to the power 5 volt or Newton meter per coulomb. Okay. Second question. Yes, second question is, what is the electric potential at the surface of the nucleus? The radius is 6.6 in 10 to the power minus 15 meter, and atomic number of the platinum nucleus is 78. That means what is the electric potential at the surface of the nucleus? Electric potential surface रे केते कार nucleus रो surface रे electric potential केते जहार कि से न्यूक्लियस रो रेडियस केते 6.6 इन 10 to the power minus 15 मीटर देछि क्वेश्चन रे, and atomic number of that platinum is 78. अपन देछि से platinum nucleus रो atomic number देछि केते 78. Now again I will repeat that question. What is the electric potential at the surface of nucleus? The radius of nucleus is 6.6 in 10 to the power minus 15 meter, and atomic number of platinum is 78 meter. So here you write V becomes question. The radius of nucleus is R equal to what? Or distance of the nucleus from the center is 6.6 and 10 to the power minus 15 meter. Atomic number of the platinum ZP is 78. You know, electric potential V equal to what? Sutra 1 by 4 pi epsilon 0 Q by R. But I don't know about charge. So charge of the platinum nucleus is given by charge of platinum nucleus is given by Z into E. So Z means atomic number of the platinum nucleus into E means charge of proton. Inside the nucleus protons are there, so here you write, that means 78 into charge of proton is 1.6 and 10 to the power minus 19 coulomb. So V can be represented as 1 by 4 pi epsilon 0 means what? We will write 1 by 4 pi epsilon 0. Q means ZE divided by R. So V equal to 1 by 4 pi epsilon 0 means 9 into 10 to the power 9. ZE means Z means 78 into charge of proton is 1.6 into 10 to the power minus 19 coulomb divided by R means what? 6.6 into 10 to the power minus 15 meter. So here in that case 9 into 78 into 1.6 divided by 6.6. Okay, this is 9, this is 19. So at that case 10 to the power minus 10 meter is here, divided by into 10 to the power minus 15 meter is 15 is here. So you write 9 into 78 into 1.6 into 10 to the power minus 15 meter taken in numerator, so it can represent as 10 to the power 5, because 10 to minus 10 plus 15, that means 10 to the power 5 divided by 6.6. Here 1.6 is there, 6.6 is there, so that means 116 by 10, that is 66 by 10. So 10 cancel out. What is there? 9 into 78 into 16 divided by 66 into 10 to the power 5. Okay, so here now cancelling 3 कि 9 3 22 3 66 2 16 2 11 22. Here you write 24 into 78 divided by 11 into 10 to the power 5. So 24 78 means what? That can be represented as 1872 divided by 11 into 10 to the power 5. That can be represented as 170.1718 into 10 to the power 5. So if you represent multiplying 100 and dividing 100, so 1.7 into 10 to the power 7 volts. So this is the potential on the surface of the platinum nucleus is given by 1.7 in 10 to the power 7 volts. Clear? Now my third question is, the potential at a certain distance from a point charge is 600 volts and the electric field is 200 Newton per coulomb. Find, एक number question, the distance of the point from the charge. Second is magnitude of charge. Again I will repeat that question. The potential at a certain distance from a point charge is 600 volts. Here the potential at a certain distance from the charge. Here this is the point P. At that point P, the potential is 600 volts and electric field intensity equal to 200 Newton per coulomb. Okay. The potential at a certain distance from point charge is 600 volt and electric potential is 200 Newton per coulomb. Find the distance of the points from the charge. So this is the charge. Now I have to calculate distance R equal question tag. Second thing is also calculate magnitude of charge. So again repeat that question. The potential at a certain distance from a point charge is 600 volts. So here this is the 600 volt at point P, and electric field is 200 Newton per coulomb. So this is the electric field intensity is 200 Newton per coulomb. First question is the distance of the point from the charge. This is the distance of the point from the charge is, now I will calculate R, and second is magnitude of that charge. तापर कौन calculate करिबा charge केते अछि magnitude ता calculate करिबा. So here third question, V is given 600 volt, E is also given, that is 200 Newton per coulomb. We have to find out R and Q. So first question, now I have to calculate R. We know electric potential V equal to 1 by 4 pi epsilon 0 Q by R, and also electric field intensity is given by 1 by 4 pi epsilon 0 Q by R square. So dividing V by E or E by V, so dividing V by E equal to what? 1 by 4 pi epsilon 0 Q by R divided by 1 by 4 pi epsilon 0 Q by R square is here. So 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 cancel out, Q cancel out. So V by E equal to what? R square by R. So that implies V by E equal to R. That means R equal to V by E. That implies R equal to what? V means what? 600 divided by 200. So cancel out. That means 3 meter. Okay. That is the R. Because 600 volt means Newton meter per coulomb. So Newton meter per coulomb divided by Newton per coulomb. So Newton cancel out, coulomb cancel out. So meter is there. So R is 3 meter. Okay. Now second question is you have to calculate magnitude of charge. So here we know electric field intensity is given by 1 by 4 pi epsilon 0 Q by R square. So at that case electric field intensity is 200 Newton per coulomb into 1 by 4 epsilon 0 means 9 into 10 to the power 9. Charge we have to calculate magnitude of charge divided by R square means 3 rho square. So again 200 into 9 into 10 to the power 9 into charge divided by 10 rho square 9. So 9 cancel out. So charge is given by 200 divided by 10 to the power 9. Means charge equal to 200 into 10 to the power minus 9. That implies 2 into here 10 to the power minus 7. That means Q equal to 2 into 10 to the power minus 7 coulomb. So the magnitude of charge is 2 into 10 to the power minus 7 coulomb, and the distance of point P from that charge is 3 meter. Okay. So this is the third question. Okay. Now fourth question. Here in fourth question, the side of a rectangle ABCD. This is the rectangle ABCD of 0.15 meter and 0.05 meter. Okay. So this is the side 0.05 meter and this is the side 0.15 meter. Okay. 2 point charges of 2 microcoulomb and minus 5 microcoulomb are placed at the corner A and C. So this is point A and this is point C. Here at point A plus 2 microcoulomb is here and at point C minus 5 microcoulomb is here. Okay, according to that question. The diagram is given to you respectively as shown in figure. Calculate the work done in carrying a charge of 3 microcoulomb from point B to D. Again, calculate the work done. Now we will find out the work done in carrying a charge of 3 microcoulomb from point B to D. B ru D को तो चार्ज को आम ना तार वर्क डन केते कैलकुलेट करिबा. So again I'll repeat that question. The side of a rectangle ABCD are 0.15 meter and 0.05 meter. So this is the side, this is the 0.05 meter and CD is 0.15 meter. Are placed at the 2 point charges of plus 2 microcoulomb and minus 5 microcoulomb are placed at the corner AC. At point A plus 2 microcoulomb is here, at point C minus 5 microcoulomb is here respectively as shown in figure. Calculate the work done in carrying a charge of 3 microcoulomb from point B to D. Now I have to calculate work done while the charge moves from B to D, that is 3 microcoulomb. Here, and fourth number question, that is fourth. So this is the diagram. A, B, C, D is here. The distance between BC is 0.05 meter and distance between CD is 0.15 meter. At point A, the charges is placed, that is plus 2 microcoulomb charge. At point C, minus 5 microcoulomb charge is here. Okay, as shown in figure. Now we have to calculate work done while the test charge, that is having 3 microcoulomb charge from point B to D. Now I have to calculate work done due to charge which is carrying 3 microcoulomb from B to D. Clear? So at that case, first of all we have to calculate electric potential at point B due to A where charge is given, due to C which is charge is given. Similarly, electric potential at D due to A and due to C. Okay, so here we write the distance between this is 0.05 meter and CD is 0.15 meter. At point A, Q equal to plus 2 microcoulomb. At point C, Q equal to minus 5 microcoulomb. Okay. First of all, we have to calculate electric potential at point B. Electric potential at point B is given by due to charge plus 2 microcoulomb due to charge minus 5 microcoulomb. So they are added algebraically because electric potential is a scalar quantity. So here we write 1 by 4 pi epsilon 0 electric potential due to point A, that means plus 2 charge divided by distance AB plus 1 by 4 pi epsilon 0 minus 5 microcoulomb charge divided by CD, sorry, DC. So here you write 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 taken in common. Here taken in common. Here my plus 2 microcoulomb means 2 into 10 to the power minus 6 coulomb. Here minus 5 means minus 5 into 10 to the power minus 6 coulomb. Here you write plus 2 microcoulomb is here, minus 5 microcoulomb is here. So here you write, that means 2 into 10 to the power minus 6 divided AB means what? AB means it is a rectangle, so side AB which is equal to side CD and side BC which is equal to side AD, so 0.15 meter plus minus 5 into 10 to the power minus 6 divided by BC means what? This means 0.05 meter. So here 1 by 4 pi epsilon 0 is here. So 2 into 10 to the power minus 6 divided by 0.15 minus 5 into 10 to the power minus 6 divided by 0.05. So here in both of the cases 10 to the power minus 6, 10 to the power minus 6 is here, so taken in common. So you write 1 by 4 pi epsilon 0 means 9 into 10 to the power 9 into 10 to the power minus 6 divided into 2 divided by 0.15 minus 5 divided by 0.05. So 9 into 10 to the power 9, 10 to the power minus 6. So you write 2 into 10 to the power 2 divided by 15, because 0.15 means 15 by 100, so 100 means 10 to the power minus 2, so here you write in numerator, so it can be represented 2 into 10 to the power 2. Similarly 5 into 10 to the power minus 2 divided by 0.5, so 9 into 10 to the power 9 into 10 to the power minus 6. So in that case, if you take an LCM, so it can be represented as 15. So 2 into 10 to the power 2 minus 15 into 10 to the power 2. Now 9 into 10 to the power 9 into 10 to the power minus 6 into 10 to the power 2, 10 to the power 2 is here, so 10 to the power 2 taken in common, again 2 minus 15 by 15. So here you write 9 into 10 to the power 9 into 10 to the power minus 6 and 10 to the power 2 minus 13 by 15. So you write 11, this is 5. So 9 into 10 to the power 5 minus 9 is 0, 13 by 15. So 3, 3, 9, 3, 5, 15. So here 39 by 5 into 10 to the power 5 minus 9 is here. That is about VB, that is volts. Similarly, electric potential at point D. electric potential at point B due to charge which is placed at point A and also charge at point C. So they are added algebraically because electric potential is a scalar quantity. So Vd can be represented as 1 by 4 pi epsilon 0 here due to point A. That means the side of AD is equal to 0.05 meter and side of CD is represented by 0.15 meter. So here you write charge means plus 2 microcoulomb, that means 2 into 10 to the power minus 6 coulomb divided by 0.05 plus minus 5 into 10 to the power minus 6 divided by 0.15 meter. So here you write 1 by 4 pi epsilon 0 means 9 into 10 to the power 9 minus 6 taken in outside into 10 to the power minus 6 is here. So here you write 2 into 10 to the power 2 divided by 5 minus plus minus 5 into 10 to the power minus 2 divided by 15. So 9 into 10 to the power 9 into 10 to the power minus 6. So if you taking LCM of that, so 15 5 means 15. So 3 into 2, that is 6 into 10 to the power 2 minus 5 into 10 to the power 2, 0. So in that case 10 to the power 2 is also taken common because 10 to the power 2 is here, 10 to the power 2 is here. So 9 into 10 to the power 9 into 10 to the power minus 6 into 10 to the power 2. So 6 minus 5 means 6 minus 5 divided by 15. So here you write 9 into 10 to the power 11 minus 5, that means 10 to the power 5 into 1 by 15. So here you write 3 by 5 into 10 to the power 5. That is volts, Vd. Okay. In both case, Vd equal to 3 by 5 and 10 to the power 5 volts. Clear? Now, according to that question, now I have to calculate electric potential at point B, also electric potential at point B. Now, calculate the work done in carrying a charge of 3 microcoulomb from point B to D. Here electric potential is there, electric potential there. There is a potential difference in between the 2 points, which is given by work done per test charge. That implies work done bringing a charge from point B to D is given by potential difference between the 2 points into charge, which is given by 3 microcoulomb. Here we write from above question, or according to question, work done bringing a charge from point B to D, from point B to D is given by W, which is equal to potential difference between the top point means electric potential at final point minus electric potential at initial point. So here you write W equal to electric potential at final point means Vd, potential at point B minus potential at point B into where the charge moving from point B to D, that means Q. That means Vd means what? Vd means here, Vd means 3 by 5 and 10 to the power 5 is here. 3 by 5 into 10 to the power 5 minus Vb minus 39 minus 39 by 5 into 10 to the power 5 is here into while the charge moving from B to D, charge is taken as 3 microcoulomb into 3. Micro means 10 to the power minus 6 coulomb. Okay, here we will write test charge Q naught equal to 3 microcoulomb, 3 into 10 to the power minus 6 coulomb. So you will represent 1 by 5 taken in common, 1 by 5 taken in common, and also 10 to the power 5 is also taken in common. 3 plus 39 into 3 into 10 to the power minus 6 is 0. That means 1 by 5 into 10 to the power 5, 3 plus 39 means 42. Into 3 into 10 to the power minus 6. So you will write what? 42 into 3 divided by 5 into 10 to the power minus 1. It means 126 by 50. Here 50 to the 100, 2.26 is here. This okay, 55, 2.52 joule. So W equal to what? W equal to 2.52 joule. So work done while the charge bringing from point B to D is given by 2.52 joule. Clear?